Hello friends, this video on relations and functions part 2 is brought to you by examfear.com. No more fear from exams. Before watching this video, please watch relations and functions part 1. Let me now introduce to a new term called Cartesian product of sets. So what is Cartesian product? Before going to the definition, let us understand the concept. Let us assume there is a set of men, Ram and Shyam. And these two guys want to marry women. And they have three choices: Sita, Geeta and Rita. Now, in how many ways this guy can marry? If you see, Ram can marry Sita. Ram can also marry Geeta. Similarly, Ram can marry Rita. In case of Shyam, Shyam can marry Sita. Shyam can also marry Geeta. And Shyam can also marry Rita. So how I got this? First I took Ram. And then for Ram, three possible combination. Ram Sita. Then Ram Geeta. And then Ram Rita. Then second I took Shyam. And then for Shyam, Shyam Sita, Shyam Geeta and Shyam Rita. So there are 6 possible ways where man can marry women in this case. When there are 2 men, Ram and Shyam, and they want to marry 3 women, Sita, Geeta and Rita, there are 6 possible ways. In Cartesian product also we do something like this only. When we have 2 sets, for example set of man and set of women, when you do a Cartesian product of this, what you get is something like this. We'll discuss this. Now, the definition of Cartesian product. Cartesian product set is the product of 2 sets. As the name says it, Cartesian product, it is nothing but product of 2 sets. In terms of sets, the Cartesian product P into Q, this is how we'll say P into Q is set of all ordered pairs whose first component is member of P and second component is member of Q. So it will be something called P by Q form. The first is from P and second is from Q. So if you see this, when you write this in the set builder form, you say P into Q is equal to PQ, P comma Q, where P is member of capital P and small q is member of capital Q. From the early example, we see when man is one set, women is another set. When I say man into women, we got this as the output. We have seen this. Now let's note some point for Cartesian product. 2 ordered pairs are equal if and only if the corresponding first elements and the second elements are equal. For example, when we say there is a set 2, 3, 2, 4, this is one set and the next set is 3, 2, 3, 4. This is another set. So both these sets are not equal because elements are same, but the first element should match to the first element and second element should match to the second element. That's how we compare when we are comparing the product. Remember, when we are comparing the normal product in that normal set, in that case the order doesn't matter. But in case of ordered Cartesian product, the order does matter. The first element should match to the first element and the second element should match to the second element. When we say A cross A cross A, this is nothing but ABC, where all ABC are part of A. And this is called ordered triplet. When we say A into finite, in A into infinite, it gives an infinite set. It makes sense when you are saying A into infinite, this is infinite. Because in math also when you say 1 into infinite, it is infinite. Similarly in sets also when you say A into infinite set, it's infinite. Because you will be creating infinite number of sets, product sets. Also, number of A cross B, number of elements in A cross B is equal to number of elements in A into number of elements in B. For example, we have seen in men case Shyam and Ram was there, I think. 2 element. In women, Sita, Geeta and Rita 3. So number of element in M cross W were 6 actually, which you can see here is 2 into 3. Also in the last example we saw there were 3 sets A, B, C, each were having 2 elements each, and the final product we got was having 8 elements. So 8 is equal to A2 into 2 into 2. So that means number of element in A cross B is equal to number of element in A into number of element in B. Similarly for 3 items, it is number of element in A cross B cross C is equal to number of elements in A into number of elements in B into number of elements in C. In the last example we have seen that this guy was having 2 elements, this guy had 2 elements, C had 2 elements. The total output we got was having 8 elements. So this proves that both are true. Let me reiterate. In ordered pair, they are equal only if first element is equal to the first element of the second set and second element is equal to the second element of second set. Also, last point to note, A cross B is not equal to B cross A. We can prove this. For example, set A has 1, 2 and set B has 3. So when this is A and this is B. When you say A cross B, this is nothing but 1, 3 and 2, 3. When you say B cross A, this is equal to 3, 1 and 3, 2. So as we have told that only the element doesn't matter, the order also matters. So in this case 1 and 3 is not equal and 3 is 1 is not equal. So A cross B is not equal to B cross A. Let's solve one problem. It says x plus 1 comma y minus 1. This set is equal to 3 comma 1 and we have to find the value of x and y. So as we have seen, these two sets are equal if first element is equal to first element of this, second element of this set is equal to second element of this. That's why we can say x plus 1 is equal to 3 and y minus 2 is equal to 1. You solve this, you get x is equal to 2, y is equal to 3, and this is the answer. Very simple question. Just you have to know that first element of set A is equal to first element of set B. Second element of set A is equal to second element of set B. Let's take one more problem where we have x and set x has 3 elements x, y, z and set P has only one element P. Now we are asked to form x cross P and P cross x. So let's form x cross P first. So to create x cross P, first let's take x, first element of x, that is x. So it is x and first element of P. There is only one element of P, so we will take P. X comma P is 1. Then we will take second element of x, y comma P, and then we will take third element of x, that is z comma P. So x cross P is nothing but x comma P, y comma P and z comma P. There are 3 elements. There are 3 different sets. Now when we say P cross x, what we do first, we take P first. So P, and then we say first element of x, P comma x. Then we'll take P second element x, that is P comma y. Then we'll take P and third element of z, that is P comma z. So these are the values of P comma x, and you could clearly see that x comma P is not equal to P cross x. Let's take one more example. We have set A is equal to 1 to 3, 3 elements. In set B we have 2 elements 3, 4, and set C we have 3 elements 4, 5, 6. Now we are supposed to find A cross B intersections. To do this, first let me find B intersection C. What are the common elements between B and C? 4, 4. 4 is the common element between B and C. So when I say B intersection C, I mean set with one element, that is 4. And now in set A we have 1, 2, 3. So when I say A cross B intersection C, I mean to say, I'll say first element of A, that is 1, comma first element of B intersection C, that is 4. Now this first element of second element of A, that is 2, comma 4. Now third element of A, that is 3 comma 4. So this is my answer for A cross B intersection C. Now let me take one more example wherein we are saying A cross B intersection A cross C. So for that, first we have to find A cross B, A cross C, and then we have to do intersection of that. So let's find A cross B. Let me do here. A cross B will say first element of A 1, first element of B 3, correct? And then we'll say first element of 1 A and second element of B 4. First element is over now for A. Now we'll take second element 2 comma 3, second element of B. Similarly 2 comma second element of B 4. Now this is over. So we'll take third element of A, that is 3 comma first element of B 3, and then third element of A comma second element of B. So this is A cross B. Similarly, let me find A cross C. A cross C is first element of A 1 comma first element of C 4. Then again we'll keep taking the first element of A until unless all the elements of C are not consumed. So 1 comma 5 second element of C and 1 comma 6 third element of C. Now let me take second element of A. So I'll say 2 and first element of C 4, 2 second element of C, 2 second element of third element of C. Similarly, this is complete, so we'll take third element of A. So it will be 3 comma 4 because A into C, third element of this and first element of C. 3 comma 5 and 3 comma 6. So this completes the whole set of A cross C. Now we have to find the intersection of this, that is the common element. 1 comma 3, is it there in this set? It is not there. So we'll cut this. 1 comma 4, is it there? Yes, it is there. This is the 1 comma 4. 2 comma 3 is there? It is not there. Sorry, it is 2 comma 4, 2 comma 5. 2 comma 3 is not there. So we'll cut this. 2 comma 4 is there? It is here. 3 comma 3 is there in set A cross C? It is not there. We will cut this. 3 comma 4, is it there in A cross C? Yes, it is there. So the common element is 1 4, 2 4 and 3 4. That means we can say A cross B intersection of A cross C is equal to 1 comma 4, 2 comma 4 and 3 comma 4. This is the answer. I hope you got the logic what we have done. We have first found A cross B and then we have found A cross C and then we did the intersection, that is we found the common element between these two sets and the common element was. Thank you. Visit examfear.com to watch free educational videos, try free online test, get the best quality study material, study from the best tutor and mentors and much more. Thanks once again.